Welcome to the next lecture of this second chapter, that is Lathe machine. In this lecture, we will discuss about the major two important power transmission systems are available in the headstock. So let us start with the first arrangement, that is the back gear cone pulley type headstock. So here we will understand how the power is transmitted from the motor to the spindle and the workpiece. And similarly, we will also understand how different speed variation can be obtained by using this particular arrangement. So first of all, let us understand the major parts available in this arrangement. So the first one, as you can see, this is the motor. Second one over here, it is called as the cone pulley, and in this particular cone pulley there are different steps are available, that's why it is called as the stepped cone pulley. Similarly over here, this is nothing but the stepped cone pulley, and this particular section shows the belt drive or the belt which connects these two particular cone pulleys. The next one, that is the with this step cone pulley there are different gears are attached in this particular arrangement, and these are nothing but the different gears available with specific arrangement. So these are the gears, and over here one particular arrangement or the lever arrangement is provided for engagement and disengagement of the gears. So these are the major parts available in the system, and over here with this particular end gear the spindle is attached, and with this spindle at the end workpiece is attached and the power is transmitted using this particular arrangement. Now let us understand first how the power is transmitted. So as you can see, when the motor operates, this motor transmits power to this cone pulley, and from this particular cone pulley, as you can see, there are different four steps are available, so this belt can be arranged in these different steps. Similarly, at whatever the step this belt is arranged at similar same steps, this belt can be arranged in this another step cone pulley. So now as we can see, the power is transmitted from the motor, and from motor power is transmitted to the step cone pulley. Through this belt connection, the power is transmitted from this belt towards the another step cone pulley. And during the initial normal condition, these gears are not attached or disengaged from these available two normal gears. So in normal condition, power is transmitted from one step cone pulley to the another step cone pulley, and as these two shafts are engaged, this is shaft 1 and this is shaft 2. These two shafts are in engaged condition, the power is transmitted from stop cone pulley to another gear available over here, and from this gear the power is transmitted to the spindle, and from the spindle the power is transmitted to the workpiece. So this is the first basic arrangement how the power is transmitted. Similarly, when the belt is connected to the different position, another power transmission can be obtained. Similarly, at the third position, at the fourth position, based on the belt arrangement, there are different variations of the speed obtained using this power transmission or arrangement. So here you can see there are four different steps are available, that means four direct speed variation can be obtained using this back gear cone pulley type arrangement. Now when we want to reduce from particular available for direct speed, if we want to reduce more, at that time back gears comes into condition, or this back gears helps to reduce the speed variation based on the requirement. So how that speed reduction can be obtained, now we will discuss. So again, See this particular arrangement, and now if we say by particular mechanism available, when we disengage these particular two shafts, now what happens? Direct speed cannot be transmitted from motor to the final spindle arrangement available. So if you see now from the motor, when power is transmitted through this cone pulley, now here these two shafts are not attached. That means the power cannot be transmitted directly to the spindle, and for that different arrangement is available. So now when the lever available over here is pressed, this engages these all four gears, and the engagement of these all four gears helps us to obtain the more speed reduction. So how, that we will understand now. So here let us say this is the gear A, this is the gear B, over here this is the gear C, and this is the gear D, and over here the spindle is attached. Now simply again say the power is transmitted from this motor, from motor to this particular step cone pulley, from this step cone pulley through this belt to another step cone pulley. Now power cannot be transmitted through this particular section. So as the gears are attached using this lever mechanism, now power is transmitted to this gear A, and this gear A is engaged with the gear B. That means power is transmitted from gear A to gear B. And here you can see gear B and gear C are connected on the same shaft. That means power is transmitted from gear B to the gear C. And from this gear C, as gear C and D are in direct engagement, that why power is transmitted from gear C to gear D. And this gear D and spindle are connected on the same shaft. That's why the power is transmitted to the spindle available over here. And the spindle now connected to the workpiece, and that is how the power is transmitted using this particular assembly. Now over here, this gear B and gear C are helpful to obtain the speed reduction, and these are the backing up gears. That's why this gear B and gear C are called as the back gears. So these are nothing but the back gears, and these are helpful to reduce the spindle speed as per the requirement. Now how the speed is reduced, so for that we will understand the simple calculation. Suppose from this particular pulley arrangement, the RPM transferred to this gear A, that is the N RPM. Now let us take an example. If gear B is 3 times gear A, similarly gear D is 3 times gear C. So now from simple gear ratio equation available, we can see that if the gear A has n RPM, gear A has n RPM, then using the gear ratio equation we can see that gear B has n divided by 3 RPM. That means RPM is reduced by the third of the regular RPM available. Similarly, gear B and gear C are connected on the same shaft. That means gear C has the same RPM as that of the gear B. Now similarly, gear C and gear D are in engaged condition, and gear D is 3 times larger than the gear C. So using the gear ratio equation we can say that gear D having the RPM, that is n divided by 9. So from normal condition of the n rpm, we have reduced the particular rpm available by the ninth of the regular rpm. That means this is how the rpm is reduced using this particular Begier Conpuli type arrangement. So now you can say that as there are four direct speeds are available, and using these four direct speeds we can obtain four indirect speed using this Begier Conpuli type arrangement. So from this particular figure available in this condition of the Begier Conpuli, we can say that there are four direct speeds are available and four indirect speeds are available. So total 8 speed variation can be obtained using this Begier Conpuli type arrangement. But here the main important thing that one need to understand is, for each and every time change in speed or change in rpm requires the stoppage of the motor, and one need to change the belt in another step con pulley or the step section of that particular pulley. So each and every time when the speed variation is required, one must need to stop the machine and change the belt, and after that the machining operation can be performed. So these result into the more time requirement during the machining operation. So this is the one and only disadvantage of this Begier Conpuli type arrangement. So this disadvantage can be overcome by using the another headstock requirement or the headstock assembly available for power transmission, that is the all geared type headstock. And in this assembly, as shown in this particular figure, one can see that there are three shafts are available: shaft 1, shaft 2 and the shaft 3. So using this pulley arrangement, motor is attached. From this motor, power is transmitted to the shaft 1, and by using the different arrangement of gears, the power is transmitted finally to the spindle. So now how power is transmitted in this particular all gear type headstock we will understand. So first of all, look over here, this socket section shown over here indicates that these gears can be moved in this shaft 1 very easily. Similarly, in shaft 3 also you can see the same arrangement. That means these gears can be arranged or moved over this shaft 3 very easily. Whereas over this shaft 2, gear D, E and F are fixed at the particular position. This cannot be moved in this particular arrangement available. So now how power is transmitted? For that you can simply see that from the motor power is transmitted to the shaft 1, and as the gear A, B and C are connected on the same shaft, so power is transmitted to these particular gears. Now from this gear you can see this gear B is engaged to the gear E. That means gear B transmits power to the gear E, and this gear is connected on the shaft 2. That means this shaft 2 also rotates. Now this gear E is connected to the gear H. That means power is transmitted from gear E to gear H, and this gear H is connected to the shaft 3. That means with the rotation of the gear H, this shaft also rotates, and the rotation of shaft 3 result into rotation of the spindle, as the spindle is connected to the shaft 3, and that is how the power is transmitted from motor to the final spindle using this geared attachment. So how much amount of the power is transmitted? So for that one can simply use the gear ratio equation. Now as one can see, the power is transmitted from gear B to gear E. That means one can write power transmitted from gear B to gear E. Similarly, another variation, that is power is transmitted from gear E to gear H. So gear E to gear H. So this connection or combination gives nothing but the one spindle speed variation that is obtained using this particular arrangement. So this gives the RPM that are transferred to the spindle using this particular arrangement. Now, other than this, how different speed variation can be obtained? So we will take one another example. So you can look over here. Now when this gear or this on this soft one, when this gear is shifted in rightward direction, this gear, or we can see another way that when this gear A is shifted towards the leftward direction, what happens? This gear A comes into the contact with the gear D. Similarly, on the shaft 3, by using the lever arrangement, when this particular gear assembly is shifted toward leftward direction, what happens? This gear G comes into the contact with the gear D. So now, how power is transmitted? So for that, simple, when the motor starts, it transfers power to the shaft 1. From shaft 1, power is transferred to the gear A. From gear A, power is transferred to the gear D. From gear D, power is transferred to the gear G. And from gear G, power is transferred to the shaft 3. And from shaft 3, as the spindle is connected with the shaft 3, power is finally transferred to the spindle. And from the spindle, as the workpiece is attached with that, the power is transmitted finally to the workpiece. So what is the speed variation obtained in this particular connection? So as we can see, A is connected to the D. That means the gear ratio obtained is GA divided by the GD. Similarly, from gear D, power is transmitted to the gear G. So the another ratio obtained, that is gear D divided by the gear G. And this combination is nothing but the another RPM variation that is transferred to the workpiece and the speed variation obtained. As you can see, there are total 9 different gears are available. That means 9 speed variation can be obtained very easily using this all gear type headstock and from this figure. So this figure arrangement shows that total 9 different speed variation can be obtained very easily using this all geared headstock. So here you can see that there is no requirement of the motor stoppage to change the speed variation. That means speed variation can be obtained easily shifting the gears inside that gearbox without stopping the machine, which helps the machining operation to be performed very easily. So total 9 different speed variation you can easily obtain by combining different gears with the different assemblies available over here. So you try from yourself to obtain 9 different speed variation that can be obtained from this particular figure or the assembly shown over here. So in this lecture we have discussed about the major two power transmission systems that can be available in the headstock assembly. The first one is the back gear cone pulley type arrangement, and the second one, that is the all geared headstock assembly. So I hope you got the clarity about how the power is transmitted from the motor to the workpiece based on the arrangement available. So looking forward to see you all in our next lecture. Up to then, thank you.